Did we already do factoring yesterday together? Okay. Well, here we go. So number 13, it says factoring the leading coefficient of 1 is pretty easy. Do you remember how to factor when the leading coefficient is not 1? So if I ask you to factor x squared minus 6x minus 160 versus factoring 6x squared minus 19x plus 10. I'm going to factor this second one two different ways because I want to remind everyone of a method that you will need to know in the future when you have no choice but to use this, okay? So we're just going to go through it together. All right, so for this one, I think we talked about this one yesterday, didn't we? We're looking for the factors of negative 160 that add up to negative 6, so that's 10 and 16, negative 16. So we just write x plus 10 and x minus 16. So if I were to distribute this out, I get x squared minus 16x plus 10x minus 160. And that would simplify down to that. Do we remember the steps of just factoring? Leading coefficient 1, factors of that add up to. Okay, so let's do this one. If I multiply this times this, because now, what method are we going to use? Yeah, we could use a quadratic formula to solve and then put them in factors, but I want to go ahead and factor first, although that's definitely a valid way of doing it. Called bottoms up. Okay, so bottoms up is the fast and quick and easy method, but as far as like proving it algebraically, it's actually kind of difficult. So what I'm going to do is I'm going to work it out, and then I'm going to show you this other method that algebraically makes sense and that is necessary in the future, okay? We multiply 6 times 10 and get what? 60. I'm looking for the factors of 60 that add up to negative 19. 1 and 60, 2 and 30, 3 and 20, 4 and 15, 5 and 12, 6 and 10. Which one of those have a sum or difference of 19? 4 and 15. Good. Tell me about their signs. Okay, both negative. So we remember from bottoms up that we write x minus 4 and x minus 15. But what do we have to remember to do because of that 6 up front? Divide by 6. So I'm going to divide this by 6, divide that by 6. Does 4 6 simplify to 2 over 3? So then what do I have to do? Good. So 3x minus 2. Does 15 6 simplify? To what? 5 over 2. It's like, yeah, well, how many? Yeah, that's really easy to mess up with that 3. Okay, so how many times does 3 go into it? 5 times and 2 times. So what does this become? Also tempting to use, but you got to remember to bring the 2 up. Yeah. Yeah, I do it all the time. Okay, so 2x minus 5. Okay, now I need everyone, okay? I need everyone to tune in to what I'm about to do, okay? So you don't have to write it down necessarily, but I do want you to tune in, okay? So 6x squared minus 19x plus 10. This is called factor by grouping, and I assume that you've been taught this at least once before when you first learned factoring. So here's the thing. We do the same thing as what we did before, 60, negative 4, negative 15, but here's what you do. You write 6x squared, you write plus 10, but you rewrite negative 19x as negative 4x minus 15x, and I got these two numbers from my two factors right there, right? Okay, now what we're going to do is it's called factor by grouping because now you group the first two terms and the last two terms. And before I do that, can I just establish something with you guys? Is it true that 2 minus 7 is the same thing as 2 plus a negative 7? Okay. Then if you're okay with that, then what I'm going to do is I'm going to put parentheses around these two. I'm going to put a plus sign in between, and then I'll put a parentheses there. The negative has to go with the 15, but I'm not multiplying these. I'm still adding and subtracting. So there we go. Okay, it's called factor by grouping because we group and now we factor. In this first two terms, guys, can you tell me what I can factor out of 6x squared and minus 4x? A 2x. And what am I left with? 3x minus 2. Okay. Plus, what could I factor out of negative 15x plus 10? How about I factor out a negative 5? Yeah? Because then I can have the same signs is this right here. If I factor out a negative 5, what am I left with? Negative 15 divided by negative 5? 3x. And then what's 10 divided by negative 5? Minus 2. Do you notice how these are the same thing? Now, so here's where there's the last step mathematically is something that people just kind of like magically do as opposed to think about it. But if I asked you to do this for me, if I asked you to factor 2xy minus 5y, what would the common factor be? Y. And so you would write 2x minus 5 is what's left over. True? What is our y? Is it just negative 2? Isn't all of this the common factor? Everything inside the parentheses, they're the same thing. So what we're doing is we're factoring out a 3x minus 2 from both. And what are we left with? And we get the same answer. Now, this is a lot more work. True? Which is why whenever it's possible, if it's a quadratic, I'm 100 times out of 100 times, I'm going to use bottoms up. But should I need to, in the case of a cubic with 4 terms, and it works out, I got to know how to use factor by grouping. Okay? When we learn it and we need it again, we'll go back over it. True? Or not true. No, it's true. It is true. I'm just telling you it's true. Okay. 14, yeah? All right, let's talk about 14. Let's do the pattern. It's kind of cool. And I'll also show you how to use your calculator to do this on the ACT, so that should be helpful. All right, what is an imaginary number? Imaginary number. You said I. What is I? The square root of negative 1. Cool. Did we go through at least the first 4 yesterday? Okay, so I'm gonna talk through them right quickly, and I'll get on the video. So I to the 0 power, anything to the 0 except 0 is 1. I to the first power is I. I squared is negative 1, because if you square the square root of negative 1, then you get negative 1. I cubed is just I squared times another I, and we already know I squared is negative 1, so that would be negative I. Are we in agreement? Okay, now I'm going to pop back up here and I'm going to say I to the 4th, because I know that I to the 4th is the same thing as what? I cubed times I. Y'all with me? Didn't we say this yesterday? And then I cubed is negative I, because of that right there. Negative I times I is the same thing as negative I squared. But I squared is negative 1, which is just positive 1. I'm back right here. Did I go through the pattern with y'all? All the way through, like, remainder and all that? Well, dang, it's not as fun. But I'll show you how to use the calculator in just a second. Okay, so for those of you in the that are watching the video that were not in my 8th period class, then say 4, 5, 6, 7, 8. I know I to the 8th should be the same thing as I to the 0 power, and here's why. Well, I don't want to do I to the 8th because that's harder to. It doesn't show the example as easily. So I know I to the 9th should be the same thing as I to the first I, and here's why. Because if I divide 4, which is the number of terms that are in the pattern, right? If I divide 4 into 9, 4 goes into it 2 times with 1 left over, and the remainder is what this is equivalent to, I to the first, which is I. Which means 10, 11, 12, 13, 14. 14, I to the 14th power, ooh, not 44th. I to the 14th power should be the same thing as I squared, and the reason why is because 4 goes into 14 3 times with 2 left over. So the number of the remainder tells me what the equivalent is. So if I asked you to tell me what I to the 2109th power is, guys, what would I do? Divide by 4. So how many times does 4 go into 21? Okay, 5 times. 4 times 5 is 20. Subtract, and I'm left with 1. Bring down the 0. How many times 4 go into 10 times? Or 4 go into 10? 2 times. Good. With how many left over? 2. Bring down the 9. How many times does 4 go into 29? 7. Good. 4 times 7 is what? 28. Subtract, and I'm left with 1. Which means I to the 2109th power is equivalent to I to the first power. So let me show you how to type that in the calculator. Do you have a calculator? Because if you do, you want to go ahead and see it. If you don't, you can borrow one of mine, just leave it on the table. But this is just something you can see later. Do you see the I above the decimal in blue? Okay. So I'm going to go second I raised to the 2109th power. I'm going to press enter. And so you have to be able to read this. So what is all this crap up here? It is scientific notation. Okay, so I know that it should be I to the first, which is just I, true? But what my calculator gave me was 4.41, ooh, that's not a 1, I misspelled 1. Okay, times 10 to the negative 11th plus I. But this right here is 4.41, move the decimal 11 places. So 1, 2, 3, 4, 11. We'll pretend like that's a lot of zeros, right? How small is that number? Pretty small. So small, might as well be what? Okay, so it's 0 plus I. So if I'm on the ACT and they ask me what the power, what I to the 2109th power is, I'm just going to type it in the calculator, and I'm going to know that anytime they tell me like this exponential expression with scientific notation, that's 0. So watch right quick. What if I do I to the 2110th? Eh! Well, that was a fail. Raise to the 2110th power. Negative 1 plus all this crap. But what do I know what this number is? So it's negative 1 plus 0I. The answer is negative 1. Eh? Okay, there we go. Alright, I'm going to end this video at 14 and then pick back up at 15 in just a second.